Welcome to this session on computational thinking for problem solving. I'm Dr. Shahan Perra from the Department of Computer Science and Engineering, University of Morocco. At the end of this session, you will be able to see what is computational thinking, why we need computational thinking, and how we can solve problems using computational thinking. This session is the first session in a series of sessions that are part of a course in Python Basics that is designed to help you to learn and get started on programming in Python. Once you get started on Python, you can also take other courses that we offer specifically designed for you, so that if you complete all the courses successfully, you will be able to become a software developer that has sufficient knowledge and skills to get started on a career as an entry-level software developer. We use a standard color coding mechanism throughout these slides to help you absorb the content that we have on these slides. So we will be using red color to indicate the very important points, and we will be using blue to indicate points that are important but may not be as important as the ones that are given in red. We will be using green for terminology and purple for other content that are slightly off topic but may be important to know. The basic outline of the session, we will cover computational thinking and a little bit about computer systems, including the history of computing. Sri Lanka is considered currently as one of the top destinations in the world to visit. Let's assume that you want to go on a trip to Sigiriya. Sigiriya is a very interesting place to visit, as it is an ancient rock fortress built by a Sri Lankan king. For some, planning a trip would be an enjoyable experience, but let's assume that it is a problem. Thinking about how do you go, when do you go, at what time do you leave, with whom do you go, what do you eat, how do you find the money, right? So we need to solve all those problems in order to go on this trip. Let's see how we can use computational thinking to solve this problem. You may be already using computational thinking to solve the day-to-day problems that you come across, but you may not be realizing it. Right. So let's look at what is computational thinking. So what is computational thinking? It can be used to solve problems. The basic problem-solving concepts and ideas come from computer science. If you can use computational thinking to solve a problem, you can also use computers to give the solution to the problem. At the moment, we have so many problems around the world. If you can at least solve a few of those problems, that would be great. Remember, computational thinking is not computer programming. In this course, you will be actually learning computer programming. You will learn the basics of Python programming. We can use computational thinking to solve a problem and then write the solution using a computer programming language like Python, and get the computer to solve the problem that we wanted solved originally. Today we use computers to solve a lot of our problems in engineering, medicine, agriculture, social sciences, military, you name any area, there would be a solution given by a computer or a computing device. That is why there's a huge demand for software developers or software engineers, people who can think using the computational thinking approach and solve these problems that are out there using computers. We also like to see those who are following these courses and completing it successfully become productive citizens of the world by solving some of these problems. We can also solve the problem of going to Sigiriya using computational thinking. There are 4 parts to computational thinking. We will look at each one of them separately with our example of solving the problem of going to Sigiriya. Once you look at the example, you will understand these very clearly. But for now, let's look at what they are very briefly. First, one is decomposition. That is to break a bigger problem into smaller parts. We can solve the smaller problems or smaller parts of the bigger problem rather than getting stuck on solving the bigger problem. That is what we do by decomposition. Once we find the solutions for the smaller parts, we can put those solutions together and solve the bigger problem that we were faced with originally. Second one is pattern recognition. In this, we try to see things that are common to multiple similar problems or similar problems, so that we can reuse the solution or a solution that we have used for one of these similar problems. By solving one of the similar problems, or by using a solution given to a similar problem, we are able to solve multiple problems by using pattern recognition. Third one is abstraction. In this, we try to focus or look at the important things of the problem, or the details that matter to solve the problem, and ignore the other things that are around it. Sometimes we get distracted by looking at the bigger problem, or by looking at all the details of the problem. Sometimes it's only a few things that we need to concentrate on solving the problem. In that sense, what we could do is we can look at an abstraction of the problem and try to solve that problem by looking at the abstraction of the problem. Fourth, we have algorithm design. In this, we come out with step-by-step instructions to solve a problem, so that we can use the steps to solve this problem later, or else we can ask somebody else to solve this problem. And in computer programming, we do that. We come up with step-by-step instructions on how to solve a problem. So fourth part of computational thinking is to come up with step-by-step instructions or algorithm design to solve problems. Decomposition allows us to break a problem into smaller parts so that we can solve the smaller parts separately and combine the solutions to solve the bigger problem. This is something that we do to solve a lot of our problems. For example, in our trip to Sigiriya, if we want to break the things that we need to solve into multiple parts and then think about those parts separately, that would make it easier for us to solve the problem rather than trying to think about the entire trip at once. In our example, rather than trying to think about what we are going to do for the entire day, why not break it up? What are we going to do in the morning? What are we going to do in the afternoon? What are we going to do in the evening? Or else maybe what we could do is we could break it into the first 50 kilometers, the second 70 kilometers, and the remaining 62 kilometers by breaking the distance of the trip into 3 parts, and then consider solving the things that you want to do separately. Also, we can break it into subparts of what food we want to eat, and maybe ask the girls to solve that problem. Or what sites do we need to visit? We can ask another person to solve that problem. Or what transport mode should we use, right? So that can be a separate part of the bigger problem, and we can ask somebody else to solve that problem. So breaking a bigger problem into smaller parts for the purpose of solving the problem is decomposition. Once we complete solving the individual parts, we have the entire solution for the entire problem. In pattern recognition, we try to see if we can find similar patterns in problems so that we can reuse the solution for a similar problem that we solved earlier. By using a solution that we have used earlier for a similar problem will help us to solve the problem much faster and efficiently. So to solve the problem of where to visit in our trip to Sigiriya, what we could do is we could check and see, did we go to Sigiriya earlier, and what are the places that we visited earlier? Or else we can ask a person who has been to Sigiriya. Rather than looking at all the interesting sites in Sri Lanka, we can look at what other people have done. We can look at how other people have solved the problem and maybe use the same pattern to solve the problem that we have to solve. For example, if you want to decide on the time to go or time to leave for this trip, what we can do is we could actually look at the times that we left for our other trips. If we have gone for other trips like Kandy or Matara or some of the other cities in Sri Lanka, what time did we leave? We can look at those time periods and maybe decide and say, okay, 8 a.m. is a good time to leave for this trip by looking at the pattern of what we have done earlier. We may not realize those are patterns that we have observed in the past and the solution patterns that we have used to solve those problems. Right? So these patterns help us to answer similar questions that we may need to answer now or today. Abstraction allows us to look at the general characteristics of the problem without going too much to details of the problem. For example, for our trip to Sigiriya, who are we going to invite for this trip? without going into the details of the specific names of people who are going to go on the trip, we can look at it from an abstract level. Is it friends that we want to invite? Is it family members or colleagues? Or right? So we can look at the problem at a higher level without going into the exact places we want to visit. We can think about the fact that we need to have other sites that we need to visit. When planning the overall trip, if we want to use abstraction, we need to look at the participants, we need to look at the cost, we need to look at the sites, right? So by looking at the list of items like this at a higher level that we need to solve, we can make it easier for ourselves to solve this problem. Abstraction helps us to solve the problem by looking at the overall problem from a higher level rather than with the minute details of the problem that we need to solve. Also, abstraction helps us to produce a common way of solving the problem and then maybe reuse it to solve other similar problems. For example, if you want to go on a trip to Matara in the south, we may be able to use the abstract level solution that we came up with for the trip to Sigiriya. Algorithm design is a way to discover step-by-step instructions on how to solve a problem. We can use the instructions to solve the problem now or later, or else we can give these set of instructions to another person to solve the same problem. For example, when we go on the trip, we will be visiting multiple sites. So what do we do at each site? Need to be decided. Coming up with the set of instructions on what we do at each site could be an algorithm design. We can also think of the overall problem of scheduling the trip as an algorithm. We plan the sites, we collect all the people going on the trip. That is an example of a sequence of things that we do one after the other. We check to see if it is raining. If it is raining, we'll have to stay in the bus the entire day. So we should take an umbrella or a cap. But if it is not raining, we don't need to take an umbrella or a cap. So we decide whether to take a cap or not based on whether it's raining or not. That is an example of a decision in an algorithm. We find a vehicle and then we start visiting the different sites that we wanted or that we decided to visit. So until we finish all the sites that we have decided to visit, we will be repeating the same thing again and again. So that's an example of repetition. We can represent this algorithm as a flowchart. We will learn more about flowcharts when we learn more about algorithm design and go further in programming. For now, think of it as a diagram that can help us to put the steps that are required to solve the problem in a diagrammatic manner. We have a sequence of steps that we do at the start of the trip. Then we have a decision that we need to make. So there's an example of a decision. And then we have to repeat something. Until we finish all the sites, we need to repeat and continue on the trip. So these three components, the sequence, the decision, and the repetition, are what we use in algorithm design. We may be using it in different combinations, one inside another one. That is how we can solve all the problems or most of the problems that are out there using algorithm design, or coming up with a collection of steps that can solve the problem. We can also represent the same solution using pseudocode. Pseudocode is a way of writing a solution to the problem in an informal way for us to represent how we solve that problem, and also for other people to understand how we have solved the problem. Pseudocode is not a programming language, but we can very easily convert the pseudocode representation into a programming language like Python, Java, or any other programming language. If we can think of getting machines to solve the problems by understanding the solution that we have come out with, that is what we try to do by building machines or computers to take each step at a time and solve the problem that we have by looking at the steps of the solution that we have given to the machine. Humans use tools to help them. They use tools or machines to solve their problems. The earliest use of a machine to solve problems of calculation or calculating is found in the use of abacus. That was able to do the additions, subtractions, and divisions and multiplications.
It does not matter whether the numbers are 3 and 5 or 300 and 500, the machine could help us to calculate the answer. But it was a very, very simple machine built for calculation only. The next computing machine we see in history was built by Charles Babbage, who wanted to come out with a machine where we can solve different problems that have different solutions. The difference engine is a machine that can be adjusted to the problem that we want to solve. It was possible to create a simple algorithm as a solution for a problem and use the engine to solve that problem. This was a mechanical machine that had a lot of wheels and arms, similar to what you see in a mechanical clock that works together to give us the time or the solution from this difference engine. Each time we want to solve a different problem, we had to change the settings of the machine by adjusting the wheels and how they are connected to each other to solve the problem. But still, it was better than the abacus, since it was able to solve different categories of problems other than just the basic calculations. After that, we see the use of electricity and electronics to build machines to solve our problems. ENIAC was one of the first computers that was able to solve different problems, and also we were able to give the algorithm to the machine in a much more easier manner than what it was with the mechanical machine. It was a huge machine, and there were a lot of devices and wires going all over the place, connecting the components and transferring the electrical signals all over the place. But ultimately, it was able to give the solution to the problem that we had given using an algorithm and representing that algorithm in this machine. Going further, von Neumann was able to separate the data and the instructions or the steps used to solve the problem from the engine or the processor that was actually solving the problem. This is like writing what you learn in your mathematics class on how to solve a problem in a book. And when you are given a problem to solve, you look at the book on the steps of how to solve that problem, take the question that is given by your teacher and solve the problem. Now, using computers, we can solve different problems with different data because we have been able to separate the data and the instructions and the engine or the thing that is actually solving the problem for us. We have computers that have separate memory to keep the data and the instructions to solve it in a separate processing unit that can take the instructions and the data and the corresponding data and give us the solution. Memory unit is like a large box where we can put all the data we want to process and also the instructions on how to solve the problem. The processing unit will take one step or one instruction at a time and also the corresponding data and process it and do the calculation and produce the result for us. Based on von Neumann's idea, we can look at the modern computer. We have a memory unit and a processing unit. Processing unit has a control unit that keeps track of the overall operations, kind of a manager of the system, and an arithmetic and logic unit that can process the instructions given to it. The memory unit has the data and the instructions. We also can connect input devices such as keyboards and thumb drives to give instructions and the data to the main unit. And we can also have output devices such as computer screens and printers to show the solution that is produced by the computing unit, the solution that is produced for the problem that we are trying to solve. If you look at a summary of what we have covered in this session, we looked at computational thinking by looking at an example of solving a problem of going on a trip. We looked at how we can decompose the problem and break it into smaller pieces so that we can solve each part separately. Then we looked at the pattern recognition to find similar patterns in problems and their solutions and then reusing the similar solution. Then we looked at abstraction to look at a problem from a distance so that we can get away from the minute details of the problem and solve it. Also, we looked at algorithms to come out with step-by-step instructions on how to solve a problem and maybe tell someone else to solve the same problem. We also very briefly look at how historically we have used computers and computing machines to solve our problems. We also looked at the different parts of a computer at a very, very high level so that we know how they are connected and how it is solving problems, or how it is getting the solution to the problem and then solving the problem for us. Now that we know about computational thinking and how to solve problems using computational thinking, we need to know how we can write the solution to the problem using a language that the computer can understand. I can tell you how to go to Sigiriya in English or Sinhala or Tamil. Similar to that, we need a programming language such as Python to communicate with the computer and tell how to solve the problem. That is what we are going to learn in Python programming. Let's meet with another session on how to solve problems using computers by writing code in Python.
Hello everyone. I'm Upeksha Ratnayaka, an IT industry professional from a company called 99X. So, in your previous lesson, you have already learned about different hardware parts of a computer. Other than this hardware which you can touch and feel, a computer also requires software installed for it to be of any use. So, during this lesson, you will learn about the different parts of a software system and why they are important. In this course, we do use a standard color coding scheme to make it easy for you to find the important points. So, please take a moment and make a note of the color codes we will be using. Will you believe me if I say that a computer is just a dummy machine without software? But that is the truth. A computer with only hardware is not at all interesting. Just like this empty CD. Look at this empty CD. Does that excite any of you? No, right? In contrast, how about this? Don't you find this movie CD very exciting? Once you record a movie into a CD, suddenly that CD becomes a great entertainment and appeal very interesting. Software is just like that. You must know that it is the software that brings the boring computer hardware to life. A computer that is made up of just some plastic and steel becomes very interesting when you have software installed on it. For an example, think of a computer with a gaming software installed. I'm pretty sure many of you love playing games on computers. However, games are not the only type of software that runs on a computer. There are other software applications such as word processor, internet browser, calculator, etc. that runs on a computer. Other than that personal software, most business such as banks, supermarkets use software to run their day-to-day business operations as well. Now, think about a bank in your city. When you go to the counter at a bank, you might have noted that the banking assistant was using a computer. I'm sure they are not playing games on their computers. To get the work done, these computers have a special banking software application installed in them. During the next few slides, we are going to take this banking software as an example and discuss the different parts of a software application. That banking software application may look like this. You can see this software shows a lot of information to the banking assistant. Also, the banking assistant can perform operations such as checking your bank balance or increasing your bank balance when you make a deposit. This part of the banking application that the users see, we call this as the user interface or the client. We also call this as front end. This front end can be web-based or desktop-based. The user interface is capable of understanding the user's actions and responding with results appropriately. For an example, the banking assistant can enter your NIC number and retrieve the information about your bank account through the user interface. As a a full stack developer, this is one of the parts of the software application that you will develop. The functionality you develop in the user interface is called the presentation logic. Now, you might wonder where all the data about your bank account is stored. Do you think the data is stored in that computer where the banking assistant was working at? If that was stored inside that computer, when you go to a different branch of the same bank, the new branch will not be able to find your data because it has a different computer. That means your data is not residing on that computer you saw at the bank, but at a different location. However, the computers at all branches of the bank are able to retrieve data from the central computer in which the data is stored. Your account data comes over the network from another computer that can keep data. We call this the database. There are many database software that is readily available. So, as a developer, you may use one of those existing database software rather than developing your own database software. However, you will have to create data tables to keep your data and insert, delete, update or retrieve data from these tables. Data handling is an important part of developing a software application. Now, let's talk more about your bank. If you have enabled SMS services from the bank, you might have received SMS from the bank sometimes at the middle of the night, indicating that your account was credited with some monthly interest amount. Were you wondering who works at the bank at the middle of the night? Now, that is not a human, but a part of the banking application that does these nightly jobs. We call this part of the software as the server. Apart from the nightly jobs like interest calculation and sending SMS, the server also acts as an intermediator between the user interface and the database. That means the server sits between the user interface and the database because the user interface usually cannot directly connect to the database. So, the server receives the request from the user interface, then communicates to the database, processes the data and sends the data back to the user interface. At a very high level, client, server and database are the three main layers of a software system. During the following lessons, you can learn how to develop each of these parts. For you to be capable of developing software on your own, it is important that you learn how to develop each of these parts. A software developer who is capable of developing all these parts of a software is called a full stack developer. With that, we come to the end of the session. So do not forget to read through the below reading content to learn more about the technologies used for developing the client, server and database. I hope you understand the main parts of a software system, the client, server and the database now. Happy learning and thank you.
Good day to all of you. Welcome to the session on setting up Python locally on your personal computer. In this session, we will look at how we can download a compatible Python installer and then install Python on your local computer using that installer. To set up Python on your personal computer, you have to find a compatible installer. I am giving this guide for Windows operating system only. However, if you are using a different operating system, you can install Python using a similar process. Please also note that we are working on Python version 3, commonly referred to as Python 3. The first step here is to open your preferred web browser and then going to python.org. Here, you can find the Downloads tab, and when you click this, it will automatically detect your operating system and provide a compatible Python version. However, as I mentioned before, if you need to download for a different operating system, then you have that option to select that too. Let me pick the latest Python version here and it will begin downloading. If you need a different Python version, you scroll down to looking for a specific release and easily find that version that you need. That's all you have to do. It's quite easy, isn't it? Once you have downloaded the Python installer, you can go ahead and install Python on your computer. To do that, first go to the downloads folder and open the Python installer that you downloaded. When you do that, it will bring up a window which we call as an installation wizard. It will help you with the installation. Here you have the option to customize the installation, but we are not going to do that here. However, please remember to tick this option, add Python version to the path. This helps us to easily access Python later from anywhere. Tick that box and select install now. It will prompt you to give permission, and since we downloaded it from official Python web page, we can go ahead and give permission to install. Now the installer will begin extracting necessary files, copying them to your system and finalizing the installation process. Okay, if you have reached this stage, then you have successfully installed Python on your local computer. Congratulations! Now that we have successfully installed Python, the next step is to check whether the installation is working. We can do that by accessing what is known as the Python console. To access that, we first need to open the Windows command prompt. Let's go ahead and open the command prompt. On this command prompt, if you type Python and press enter, then if the Python installation has correctly installed Python, it should bring up the Python console. As you can see here, this also shows us the Python version, which is the latest version that we installed. Through this console, you can issue various Python commands, but we are not going to cover that here. In order to exit from the Python console, you can type exit with open and closed parentheses. That brings us to the end of this session. So as a summary, during this session, we installed the latest Python version on the Windows operating system, and then we checked the Python installation by accessing the Python console through the Windows command prompt. If you have successfully followed this session, then you should be able to have access to a working Python version on your personal computer. Let's move on to the next session with that installation. Thank you. Welcome to this session on my first Python program. I'm Dr. Gayashan Amarasinghe from the Department of Computer Science and Engineering at University of Moratuwa. So at the end of this session, you will be able to create your first Python program and also get to know a few tools that are available to succeed in this course. We use a standard color coding scheme to make it easy for you to find the important points in the slides. So please take a moment to learn this color coding. So what is programming? When it comes to computers, programming is giving a set of instructions to a computer to follow. By following and executing these instructions, the computer is expected to complete some tasks. So this is quite similar to instructions that you give to other people, like a family member or a friend or some random person that you meet on the road. You use a language understood by both parties and give instructions using that language. Let's see how you would give instructions to another person using a language understood by that person. We'll be using the English language here. Go to the supermarket and get 3 loaves of bread. If there are eggs, get 4. This is a set of instructions that can be understood by the listener. If it was given to you, you can execute these instructions. So what about a computer? Can you give the same instructions to a computer and get it to do the same thing? Well, the answer to that question is yes and no. Yes, you can give the instructions to a computer and ask it to execute them. However, the instruction should be in a format that the computer can understand. So now, if you give the same instructions that you give to a person to a computer, the computer will not understand them. But there are established ways of giving these instructions to computers. Let's look at how we might give the same instructions to a computer. It looks somewhat familiar, isn't it? Can you understand what's going on here? The structure of how these instructions are formed seems to be different to English language instructions, even though you can read it and understand what's going on there. To describe it in a very simple manner, this is what programming is. As programmers, we are preparing a set of instructions in a way the computer can understand, using a language the computer can understand, just like we did when communicating with people. We use the English language then. And here we are using some other language that the computer can understand. If our set of instructions are correct, then the computer will be able to achieve the task that we are asking it to perform. So what is Python? Python is such a programming language that a computer can understand with some help. Python allows us the programmers a way to prepare the instructions we want to give to a computer using the rules of the language. These instructions are understood by the computer with the help of a tool called Python Interpreter. Python Interpreter is another program or a software that reads Python instructions, also known as code, and performs them or execute them on the computer. So we can use the Python language by working with the Python Interpreter. We are not going to discuss more details about the Python Interpreter in this session. However, if you are interested in learning about it further, please refer the Advanced Python course modules. There are two common ways for us to use the Python language or the Python interpreter. With the interactive mode, you can execute a single line of Python code, get the output and enter another input later. With the scripting mode, you can set up a collection of Python instructions, also known as Python code, and execute them. We'll look at these two modes later on. Let's try our first Python program. This is a very common first program in many programming languages when you are learning it. We call this a Hello World program. In this program, we want the computer to print Hello World. We can do this using the print command in the Python programming language. This is the command. And when you type this command, it gets executed, and when you execute it, you get this output. This is considered as the output. Even a single command is considered a program. Of course, you will be writing more complex programs in the future. Let's see how we can execute this program in our computer. Remember the two common modes of using Python? Let's see how we can use these modes and execute our first Python program. This is the interactive mode where we get the prompt to enter Python commands line by line. We can type a command and press enter for it to execute. Then the prompt is returned for us to enter another command. This is known as the interactive mode. It goes back and forth like this, taking in a command line by line and executing each line as soon as it is entered. As you can see here, our first Python program is executed using this interactive mode. The other common mode of executing Python commands is to use the scripting mode. In this mode, we will be creating a text file containing a collection of Python commands. Then we can save that file with .py extension, and then using the command line, we can execute that file. This mode allows us to create a program with many lines of codes and execute those lines all together. As we can see here, both print commands in the file will be executed when we execute this file. These are the common tools available in our personal computer to execute a Python program. Let's see what are the other options available to us. Throughout this module, as well as other programming modules in this course, you will encounter activities designed to test your knowledge. we are using a tool called CodeRunner to implement these activities. We call them CodeRunner quizzes. Now I'm going to show you how to access a CodeRunner quiz and introduce this valuable tool to you. I'm going to show you an example CodeRunner activity that I have created for this video. When you click this activity, the quiz will open up. You can see the details of this quiz on this page. First, the name of the quiz is available, and then you can see when the quiz was made available or opened, and the deadline for the quiz or when it closes. After this closing date and time or the deadline, you will not be able to access the quiz. If you have attempted the quiz at least once before, then you may be able to access your attempts but will not be able to submit an answer for those attempts after the deadline has passed. Then a description of what the quiz is about is shown, followed by how many attempts you are allowed to attempt the quiz. If this is not shown, then you will be allowed to attempt the quiz unlimited times. Next, the grading method for multiple attempts is shown. Here, the highest grade out of the 2 available attempts will be considered when grading this quiz. Now we know the details of this quiz. Let's attempt it. This is the quiz activity. As you can see, the blue color section shows the question. In this case, you are being asked to write a Python program that prints hello world. You are also given the expected output of your Python program. In the answer box, you are expected to type your answer. If you click the check button, then your answer will be checked against the expected answer. The CodeRunner will give you feedback afterwards. Let me type an answer and check. It seems like my answer is incorrect, as shown by the red crosses and the red color feedback. I can click the Show Differences button to see what I have done wrong. Oh, I have missed a comma. Let's correct that in my answer and recheck. Great. Now my answer has passed all the tests. Now I can finish this attempt and submit the answer to the quiz. Once I do that, it shows me a summary of my answer. So this is a CodeRunner activity. You will encounter them throughout this course, and they will help you to check the knowledge you have gathered. So get yourself familiarized with them and make the best use of them. Next, I am going to show you another tool that allows you to try Python programming on your web browser inside the course modules. This tool is known as Trinket. As you can see here, this tool gives you a text editor where you can type your Python program, and then you can execute the program using the run button. Let's try it out. So when I run the program, it shows the output. This tool will be helpful to you and will be available in all Python course modules. If you want to increase the font size of the editor, you can click this hamburger menu and scroll down to select the preferred font size. Try out Trinket and see what other options are available to you. This brings us to the end of this lesson. In this lesson, we learned about what programming is, how we can access the Python programming language, and how to execute our first Python program. We also learned about 2 important tools, CodeRunner and Trinket, that will help us throughout this course. So we hope you enjoyed this lesson. We'll meet again in the next lesson. Thank you and have a great day.
Hello and welcome to this lesson on expressions and statements. This lesson is part of the course Python for Beginners. In this lesson, we will discuss about the basic building blocks of Python programming language. This will get you started with the basics of writing programs using Python language. This is the standard color coding for the presentation slides. Let's first look at constants. So what are constants? Why do we call them constants? We call them constants because their values do not change. They are fixed values. Constants can be numbers, letters, or strings. We can have numeric constants or string constants. String constants are usually enclosed within single quotes or double quotes. What happens when we pass a constant to the print function? It basically prints the value of that constant to the console. For example, when we say print 1, 2, 3, Python prints 1, 2, 3 onto the console. Now we move on to introduce variables. This is a very important concept in computer programming. We need to deal with data all the time. A variable is a named place in the memory where a programmer can store data. This stored data can be later retrieved using the variable name. Choosing the variable name is up to the programmer. You can even change the value of a variable at a later stage. This is where a variable is different from a constant. Now look at this example where you have the variables x and y, and the values assigned to those variables are 25 and 50. Later, you can change the value of x to 200, for example. So in this example, variables x and y carry numeric values. In a typical Python program, we can identify different types of statements. We have some examples here. The first one you see is called an assignment statement. There we assign the value 5 to the variable called x. Secondly, also we have an assignment statement, but this time with an expression. You see the numeric operator there, which is the addition of value 5 to the variable x. Thirdly, you see a print statement where we ask Python to print the value of variable x to the console. Going deeper into the assignment statement where we assign values to variables. In this statement, the left-hand side, we have the variable to store the result. In other words, the variable name. On the right-hand side, we have the expression to be evaluated. Up until now, we have seen some basic expressions in Python. Here, we look at numeric expressions, which include numeric operators. You will notice familiar operators like addition, subtraction, and multiplication, and also some not so familiar operator symbols. For example, the operator symbol for multiplication in Python is the asterisk. Slash for division, double asterisk for power notation, and percentage symbol for the remainder, and so on. Now, what to do when there is more than one operator at the same time? This is a common issue even when it comes to regular mathematical operations. This is why we need to have an order of evaluation. This concept is called operator precedence. It helps us to decide which operation to do first and which one to do next, and so on. So we can understand the need of a set of rules for operator precedence. Here are the rules. Parentheses should be evaluated first, and then look at exponentiation. Multiplication, division, and remainder operations come next. Then comes addition and subtraction. Left to right rule is the last in the list. Now, how do we apply those rules to evaluate this expression and get the result? To make things simpler and understand better, we can write down the statement and go step by step. We have no parentheses in this example, Of course, if we had parentheses, this would have been much less complicated. We do have exponentiation, that is 2 to the power 3. That is denoted with double asterisks. It should be evaluated first, as it is the highest priority operation we find in this example. The result of step 1 is 8. Then in step 2, we have both multiplication and division, which are similar in priority level. So we apply the left to right rule and we find division before multiplication. So in step 2, we divide 8 by 4, resulting in 2. Step 3 is straightforward, as we will do multiplication before addition, which results in 10. And at the last step, we only have addition to perform, and the final result is 11. Note that Python will do all these operations for you in the correct order. Now, let's ask Python to do this for us. I'm using the tool Trinket to do this demonstration. Let me write the expression x is 1 plus 2 to the power 3 divided by 4 multiplied by 5. In the previous slide, we have evaluated this expression using precedence rules. Now let's see what Python can do. Let me also add the line print x, which will print the value of x. Let me execute the program. Now you see we get the value 11, and that is the expected result. However, there's a slight difference. What is that difference? The Python output here is 11.0 rather than just 11. You will learn about this difference in a future lesson. It is important to remember the rules from top to bottom. It is good practice to use parentheses when writing programs so as to minimize possible confusions. Keeping mathematical expressions simple is important so that it can be easily understood. One thing to recommend would be to break long mathematical operations into smaller, less complicated steps. That way, the program you write will be much more readable and easier for someone else to understand. That is the end of the lesson on expressions and statements. In the next lesson, we will discuss about variables and data types. Thank you.
Hello everyone. Under this section, we will look into variables and data types used in Python language. Thus far, you have seen how to write expressions in Python. Variables and data types would be the core concept when writing expressions in fact-accomplished program. Let's find out more in detail about variables and data types for Python programming. This is the standard color code we will be using throughout this lesson. Please take a moment and have a look. The outline of this section is to discuss variables and data types in programming as a generic concept. Then we will move into basic data types used in Python language. Then we will discuss the objects as Python's abstraction of data, variables as object names, and the mutability of objects. In the previous section, you learned how to write expressions in Python. There you were given a brief introduction to variables and how to use variables in Python expressions. Again, let me ask, what is a variable in programming? Why do we need variables? Generally in programming, a variable simply would be introduced as a symbol which stores a value. The value could be any type supported by the programming language, and the value assigned to the variable could change over time. Using the variable or the name of the variable, we can later refer to the value stored in the variable. Thus, we can consider a variable as a temporary storage for the information that is necessary for a program during the lifespan of that program. Let's take the Python expression x equals p plus q. Here, x, p, and q refers to the variables. These variables could represent numeric values, string values, and Boolean values specified by the programming language. We refer to these specified types as data types in programming languages. Let's discuss data types in programming. What is a data type in programming? Why should we concentrate on data types while programming? Let's have a detailed discussion. Our interactions, or the inputs and outputs with the program, are treated in many languages as a stream of bytes. These bytes represent data that can be interpreted as represented values that we understand. Additionally, within a program, we process this data in various ways, such as adding them up or sorting them. This data comes in different forms. Examples include your name is represented as a string of characters. Your age would usually be an integer. Thus, the major concern of programming is how to manipulate and represent data that we want. Thus, data types are core components in programming. In programming, data type, or simply type, is an attribute of data that tells the compiler or the interpreter how the programmer intends to use the data. Most programming languages specify various types of data, which generally includes integers, real numbers, strings, and booleans. This data types defines the operations that can be done on the data. As an example, adding two integer versus adding or concatenating two strings. Also, data types define the meaning of the data. As an example, your age would be an integer. Furthermore, data types specify the way values of that type can be stored. This means most of the time how many bytes should be utilized to store an integer or a floating point number.
Especially in Python, 5 main data types could be identified, which include
3 numeric data types. In a Python program, if you need to represent numbers, the 3 numeric data types could be used. The first numeric data type is int, which is used to represent integers. Float data type, on the other hand, could be useful to represent real numbers. Mathematically, we know integers and non-integers are identified as real numbers. Thus, in terms of computing, real numbers are called floating point numbers. In Python, float data types become handy when we want to represent real numbers in a program. Python provides another data type, namely complex. The complex data type is basically used to represent complex numbers in Python programming. Also, the terms illustrated in red color are keywords in Python. That means these words have a special meaning. You cannot use them arbitrarily in a program. The next data type would be bool type, which represent Boolean data. This is also a subtype of int to represent true-false type of values in a Python program. Then another data type is string data type, which represent strings in Python. String data type represent string data, or basically data with a set of characters. We have other compound types or composite types in Python. We have already seen 3 basic numeric types and string and bool types. These could be called in a way as basic types. Therefore, compound types means collections of basic types like list, tuple, dictionary, and set, which are considered as basic data structures in Python. Let's proceed and try to understand these basic data types. Here I have illustrated the interactive mode of Python, and the 3 greater than signs refers to Python prompt where we can evaluate Python expressions. As the first example, I have typed A equals within double quotation ABC, then plus sign, and within single quotation XYZ. When we want to declare a string, we can use characters or set of characters within a single quotation or a double quotation, which Python accepts. Let's see what A evaluates to. We get A equals ABC XYZ, where the above expression has concatenated two specified strings. This is a standard procedure where we can concatenate two strings. Next, try to explore the data types in Python. Let's try to find out the data type of A. We can use built-in function type to figure out data type of a variable. You can press type within brackets A and check the data type of the variable A. This gives class str, which refers to string data type. Let's try out more examples. Here I have assigned variable B with value 64, and this will assign integer value 64 to variable B. We can check the data type of variable B, which validates B as an integer variable. Let's check the data type of value 64.0. This is a float type value. The decimal point dot has made the change between 64 and 64.0. This is how Python distinguishes integers and floating point values. Moving into more examples, try to validate expression C equals 10 greater than 5. This validates to true, which is a Boolean value. If we check data type of variable C, it will return bool as the type. We know Python also specifies complex as a data type for complex numbers. Generally, when we define complex numbers, we have to use two numbers with one number indicating the imaginary part of complex number. The number representing the imaginary part is concatenated with the symbol I, but in Python, instead of I, we use J. Let's declare a complex number, D equals 2 plus 3J. And when we check for the data type, we get type as complex. Let's move into objects. What are objects? Objects are Python's abstraction of data. This means how data is identified, treated, and discussed. Thus, in Python, data is identified as so-called objects. Thus, everything we discussed until now, integers, floats, bools, and strings, so on and so forth, could be identified as integer objects, float objects, bool objects, etc. So the data in a program is represented by objects or relations between objects. So when we talk about objects, some properties of objects could be observed. These properties are necessary to understand how objects behave. Moving into properties of an object, every object has an identity. We know data resides in memory. Thus, the object associated with that data has a memory address which points to the location of data. This identity never changes during the lifespan of a program, and we can use ID function or the is operator to validate identity of an object. Then every object has a type. This simply means the data type of associated data with the object. We can use built-in function type to check the data type of an object. Finally, an object has a value. If we create an object with integer, the integer value of the data could be referred to as the value of the object. In Python, we refer to the name given to an object or a name associated with an object as a variable. As we discussed before, variables are just symbols that store values. In Python, we can think of variable as a name given to an object, which we can later use to refer to the object. An object may have 0 one or more names. The name is also identified or called as a reference, an identifier, or as usual, a variable. To name a variable, there exists a convention that you should follow. A variable name should only start with a character from A to Z, either in lowercase or uppercase. Also, a variable name could start with an underscore symbol. Then we can include digits, letters, or underscore symbol in a variable, but not symbol like plus sign or dollar sign. Also, variable names are case sensitive. That means if you have the same variable name with lowercase and uppercase, those refer to two variables. Furthermore, you cannot use reserved keywords in Python for variable names. Let's discuss the mutability of objects in Python. What is mutability? Mutability refers to whether we can change the value of an object. If the value of an object can be changed, it is a mutable object. Otherwise, it is considered as an immutable object. Furthermore, mutability depends on the data type or simply the type of an object. Numbers, strings, tuples are considered as immutable objects, while lists and dictionaries are mutable. At this point, we have only seen numbers and strings. In next lessons, you will get to know lists, tuples, and dictionaries. Let's try to validate the immutability of numbers. Here, I have written an expression x equals to 88. Then another expression y equals to x, and it is executed, and the value of y is returned as 88, which is the same as for x. If we check the identity of x with the id function, we get a memory address of 15 digits, and we get the same identity for y, which indicates that x and y both refers to the same object. Let's try to assign x with the new value, 89. If we retrieve the value of x, it would be 89, and the value of y is still 88. If we check the identity of x, it has changed, while the identity of y is still as the previous case. Let's try to understand the previous example in depth. When we create a variable x with value 88, it has created an integer object with the given memory address or the identity. When we evaluate the expression y equals x, there is no need to create a new object, and Python will assign the same object to y as well. Since numbers are immutable, when we change the value of x to 89, it will create a new integer object and assign x to new object, while y will remain the same. Therefore, the identities have changed. Let's try to understand the immutability of strings. Here I have created a string object with value abcxyz and have assigned it with the variable a. You can retrieve the value of the variable a, which validates the assigned value to variable a. If we check the identity of the variable, it will return a memory address, which is an integer. Let's assign variable a to the new variable b and check for the identity of b. The identity of b will be the same as a. In strings, we can use the square bracket operator to retrieve a character or set of characters in the string. As you can see, the 0th index character of a is a, character at index 1 is b, and if you retrieve character at index 2, it will return character c. If we use is operator to check whether a and b refers to the same object, it will return true as expected. If we assign a new value to b, a new string object will be created with new value, and the identity would also be changed. Furthermore, if we try to change the value of the string object using square bracket operator, it will throw a type error, as strings are immutable objects. In this case, a new object will not be created. We have reached the end of this lesson. In next lesson, you will get to know about operators in Python. Happy learning ahead.
Hello, and welcome to this lesson on operators. This lesson is a part of the course Python for Beginners. My name is Buddhika Karunaratne, and I am from the University of Moratuwa. In this lesson, we will discuss the different operators available in the Python programming language. This is the standard color coding for the presentation slides, and it is consistent with all the presentations in this series. Let's first look at what an operator is. Operators are used for performing operations on variables and values. And what are operations? The simplest operations we know are addition and subtraction. The values that an operator acts on are called operands. In this example, plus is the operator, x, a variable, is the first operand, while 5, a value, is the second operand. Arithmetic operators are used for performing common mathematical operations in Python. The table you see shows Python's arithmetic operators with their symbols and meaning. We have the basic arithmetic operations, addition, subtraction, and multiplication. Then we have two types of division, standard division and floor division. Standard division always results in a float or a floating point number, whereas in the floor division, the fractional portion of the result is truncated, is removed, in other words, and only the integer part is kept. You can see in the examples how the division of 12 by 5 results in 2.4 and 2 with the two different kinds of operators. And also, we can have the exponentiation and modulus operations as well. Assignment operators are used for assigning values to the variables or any other object in Python. For instance, x equals 5 is a simple assignment operator that assigns the value 5 on the right to the variable x on the left. There are also multiple compound operators as depicted in the given table. For example, x plus equal sign 2 adds 2 to the variable x and assigns the result to x. This is equivalent to x equals x plus 2. And hence, the value of x will be 7. You can go through this given table to learn about all the compound operators in Python. It's kind of straightforward to understand. However, if you feel uncomfortable with using compound operators, you can always go for the more regular and generic operator type. So in that case, you can just use the regular operators as shown in the alternatives. Let's move forward to the next type of operator. So here, comparison operators. They are used for comparing two values. Since it returns either true or false, comparison operators are typically used in Boolean contexts. They are especially used in conditional and loop statements in order to direct program flow. And you will see this in a later session in detail about this. We have greater than, less than, equal to, not equal to, greater than or equal to, and less than or equal to as comparison operators. As we can see here in the example, the result is a Boolean value. 5 greater than 2 returns true, while 4 is not equal to 4 returns false. It always returns a Boolean value, either true or false. Logical operators and or and not operators are used to compare two conditional statements. The logical operators modify and join together expressions evaluated in a Boolean context to create more complex conditions. When using the AND operator, the expression will only return true if both operands are true. Whereas using OR operator will result in true if at least one of the operands is true. Finally, the NOT operator will only give true if the Boolean expression in the operand is false. Identity operators is and is not are used to compare two objects. Not if they are equal, but if they are actually the same object located on the same part of the memory. Hence, two equal objects do not necessarily imply that they are identical with the same identity. Here is an example of two objects that are equal but not identical. X and Y both refer to lists containing the same elements. They are equal but not identical, as they do not reference the same object in memory. So when you try X is Y, it will return false. You can verify that X and Y do not refer to the same object by using the ID function as shown on the right side. When you make an assignment like X equals Z, Python merely creates a second reference to the same object. Therefore, when you try X is Z, it returns true, because basically it is the same thing. As you can see, both X and Z have the same object identity. Membership operators in and not in are used to test whether a value or a variable is found in a sequence. A sequence can be anything from a string, a list, a tuple, a set, or a dictionary. Similar to identity operators, membership operators also return Boolean values, either true or false. For example, here we have a list with A and B. The statement A in list returns true, because actually the item A is included in that list. The statement C not in list also returns true, as C is not an element in that specific list. Now let's look at bitwise operators. These are similar to logical operators, but treat operands as binary values and operate on them bit by bit. For example, 5 is 101 in the binary format, and 7 is 111. When you perform the AND operation on these operands, it will give you the output 5, 1, 0, 1 in binary form. Since you performed a logical operation on each bit of the numbers, one at a time, this is precisely the same when you perform OR and XOR, that is exclusively OR operations, but using the appropriate logical operation bit by bit. Exclusive OR or XOR will return true only if one bit is true, not the both of them. You also have the right shift and left shift operators. Left shift shifts left a binary value by pushing zeros in from the right and letting the leftmost bit fall off. Right shift, on the other hand, shifts right by pushing copies of the leftmost bit in from the left and letting the rightmost bits fall off. In Python, an integer is usually represented in 32 bits. When you ask it to shift an x left by 2 bits, it takes the 32-bit binary representation of x and shift it right by 2 bits, as shown in the example. The resulting binary value is 20 or 20. Similarly, you end up with 1 after right shifting x by 2 bits. With that, we will end the lesson on operators in Python. We will see you in another lesson in this series. Thank you.
Hello everyone. Thus far in the Python for Beginners course, you have been looking at simple, sequential programs and operators used to write them. But let's try and make our programs a bit more intelligent and exciting with conditional execution. This is a standard color coding we will be using throughout the presentation. Here, we will learn how to make our program make decisions. In our very basic Hello World program, the program would simply greet us with a simple greeting. But what if we wanted to make the program a bit more intelligent? What if we wanted the program to greet us according to the time of the day? Good morning before 12 o'clock and good afternoon after 12 o'clock. Here's how we can code that. As you can see, we have an if statement and it is very intuitive. For this example, I have set a variable called time to 10. Assume it's a 24-hour clock. The word if is a keyword in Python, and this keyword is followed by a logical expression that returns either true or false. Also note the colons at the end of these statements. You can see the use of comparison operators here. In this line, the less than operator checks if the time is less than 12. If it is, it returns true. If it is not, it returns false. Notice also these leading spaces. Unlike many other programming languages, leading spaces like these carry syntactical meaning in Python. You can use a tab or spaces to make this indentation. These white spaces are used to mark the scope in Python. What this indentation means is that this block of code will be executed only if this if statement returns true. In this case, time is less than 12. Therefore, this block will be executed. With the second if statement, the program checks again to see if time has passed 12. Since this returns false, this block of code will not be executed. The last line will be executed regardless of the time since it is not under a condition. If instead our time was set to be 14, which would mean it's 2 p.m. in the afternoon, the first if statement returns false, and the code indented under the second if statement will be executed since the second if evaluates to true. Else is another keyword in Python. If you need your program to decide between two things, we can use an if and an else like this. The else evaluates to true only if the if statement evaluates to false. As you saw earlier, else is not compulsory. Elif is a similar keyword. This word is a combination of the two words else and if, and remembering it as an else if might actually help you understand the function. Elifs are used to create multi-way if statements. When the code is executed, it first checks the first if, and if it evaluates to true, we skip all the rest. Else if it evaluates to false, we go on to check the elif that follows. And if this evaluates to true, we don't check the elifs or the else that follow. So how is this any different from the code here? In this code, the first if condition is evaluated, and if it returns true, the code indented will be executed. But then, regardless of whether the first if condition returned true or false, the program will check the next if statement. Functionally, in this example, they return the same output since the marks are broken into intervals that don't overlap. But let's look at a program where the output differs. Check out the two pieces of code provided here. Note that for a given integer value for x, multiple independent statements may return true, unlike in the previous example. Take a moment to figure out what the output would be for the two cases. Here we go. I hope you got it right. In the first case, since the first if returns false, we go and check the first elif, and since it returns true, it does not check any further. But in the second case, even after the first if returns false and the second if returns true, and we print over 5, the program goes on to check the other statements too. In today's lesson, we checked out several options we can choose from to implement conditional execution. Which of these structures you choose to use is totally up to you. Which construct is most suitable for use depends on the problem and the solution you are designing. Often in programming, it is useful to visualize your solution before you actually start coding. Here is how you can visualize each of these blocks. I will briefly walk you through the diagrams, but make sure to pause the video and try to relate these diagrams to the actual code we saw earlier. First, the simple if statement. The program checks if a certain condition is met. And if the condition is met, it takes certain actions and then continues with the rest of the program. But if the condition is not met, which would mean if the condition returned false, we do nothing and simply continue with the rest of the program. Now take a look at the visualization of the if-else block. Just like the first if statement, we check to see if the condition is met, and if it returns true, we execute a block of code. But notice what happens if the condition returns false. We do that only if the condition returns false. Notice the difference between the two if constructs, the basic if and the if else. While we only use the one side of the condition with just the if statement, we use both parts when we use an else. The third diagram visualizes a block with an if, elif, and an else statement. Notice how when the first if statement or any of the subsequent elif statements return true, we do not check the following elif statements. If the first condition returns true, we ignore all the elifs that follow. Else if the first condition returns false, only then will we check the next elif. See why I said it's easier to remember the function of an elif if you remember it as an else if, and the same goes for this elif. Though for this visualization purpose, we have used only one elif, there can be multiple elifs following. The next elif in line is only checked if this elif returns false. And finally, if the if statement and all the elif statements return false, the code under the else statements will be executed. With that, we come to the end of the lesson on conditional execution. In the next lesson, you will learn about collections.